So if you're in my integrated computer science class, then you should have already installed the Anaconda package. Anaconda is a lot of things. It includes several developmental tools, but it also includes a complete installation of Python, including several packages that are very useful as you continue to explore Python. What we're going to do right now is to begin to use Python, write some programs, see what it's capable of. And the first thing that you need to do in order to start is open a command window. In Windows, this is how you do it. In Mac, you'll need to do it another way. I've got two displays here. There's mine. Okay. So you just type Python. It should be in your path if you set up Anaconda correctly. So you just execute that. So now you are in the Python prompt and you can begin running commands. So we're going to write our very first program here. It is traditional, exclamation, we're excited. It's traditional for Hello World to be your very first program anytime you're learning a new language. So there it is, that's the program, we're done. Turn off your computer, go home. Why is that a complete program? Maybe if you have experience with other programming languages, you're used to there being more overhead. You have to have more lines before this or after this. You're used to maybe having to compile the code to build it before you can execute it. Why is this a complete program on one line? We hit enter, we got an output. Python is an interpreted language, which means that Python is taking that code that you write, as source code, interpreting it line by line or in groups of lines. And that means executing it, taking those lines of code and running it, and then giving you some sort of output. As opposed to a compiled language where you write all your source code, a compiler translates all of that source code into object code or executable. That's similar to an application or executable program that you're already used to. And now that program can be run without further reference to the original source code. Whereas an interpreted language always needs that original source code if you're going to keep running it. We can basically write a lot of instructions line by line in Python and see the results. You can even write loops and things like that where it's interpreting more than one line at a time, but it's interpreting small blocks of code at a time. But it's not the most useful for us to just be using Python as a calculator, right? What's going to be more useful is if we can take values, store them into some variables, and then begin operations on those variables. So the way we define a variable in Python is we just type it. There we go. There's a variable x. We can store in a value, say 5, and then if we want to print the value of x, there it is. It's 5. Boom, done. If we want to change that value to 10, and we want to print the value of x, it's 10. Boom, done. So when you give the command x equals 5, the first thing the interpreter does is to create a variable called x. You can think of this like a box with a certain amount of storage available for different values. And since you've told it what the first value you want is, it's 5, it puts that 5 into the box. And then we use the print x command, you're asking it to look inside the box and then show that on the computer screen. So here is my computer screen. and it shows a 5, right? Later, when you say now x is equal to 10, the box is already there, but you're overriding the 5 that was there, and you're putting in the 10. So now when you ask again to print x, of course, you're going to see a 10 instead of the 5. The box remains unchanged the entire time, but its contents become updated every time there's a new assignment. So the equal sign isn't like the equal sign in math, where it's demanding that both sides of the equation are always equal, or even asking if both sides of the equation are equal. It's sort of an arrow pointing this way, saying store this value into the variable on the left. But what if we tried this? X is equal to pumpkin. We say print x. Now x is a pumpkin. Okay? So instead of it being a numerical value, now it's what we call a string. It's a set of characters. It's a word or a sentence or phrase or just random sets of characters. So we can put lots of things in this box, and Python is just fine with this. Other languages would not be fine with this. X is what we call dynamically typed. It can take different types of values. And in fact, in Python, we have 4 primitive types, basic types of variables. And those primitive types are integers, floats, booleans, and strings. Integers are what you already know from math class, are integers, right? So all those things, right? Floats are basically real numbers, right? They're decimal values. 1.003, right? Or 1.15 times 10 to the 15, right? They're real values except the set of integers. You want to be more technical. Booleans are true and false. And then strings, we basically discussed, they're sets of alphanumeric and special character characters. So it can be ham sandwich. It can be 4 and let me put an ampersand there. 7 years ago. Right? And it can even contain, like I suggested, special characters. So one special character is a \n. So if you do p\nq, next time we'll try this and we'll see what happens.